Solve the system by substitution or elimination. If the system is inconsistent or has dependent equations, say so. Here we have a system of 3 equations and 3 unknowns. Let's start by identifying these as equations 1, 2, and 3. Now, we're going to choose to eliminate a variable, and I'm going to pick on this variable x because our coefficients are going to be pretty easy to work with. Now, let's choose equations 1 and 3, and let's eliminate the variable x. To do that, we need to fix one of these equations. I'm going to multiply equation 1 through by a -1 so that we can create coefficients here that are additive inverses. So equation 1 becomes a -3x minus 5y minus 3z is equal to -2. So that was -1 times equation 1. Let's just rewrite equation 3 now. It's 3x plus 10y minus 2z is equal to 6. Adding these equations together, our x variable eliminates, and we get a 5y minus 5z is equal to 4. I'm going to identify this as equation number 4. Now let's go back to our original 3 equations, and let's select equations 1 and 2 and eliminate the variable x again. Here I'm going to fix equation number 1 by multiplying it through by -2. So that equation 1 then becomes a -6x minus 10y minus 6z is equal to -4. So that was equation 1 multiplied through by a -2. Let's just write equation 2 underneath it. 6x plus 5y plus z is equal to 0, and let's add these equations together. Variable x eliminates. We get a -5y minus 5z is equal to a -4. I'm going to call that equation number 5. Now let's focus on these 2 equations, numbers 4 and 5, and let's solve this system for either y or z. I'm going to use elimination with them. Rewriting equation 4, 5y minus 5z is equal to 4. Rewriting equation 5, -5y minus 5z is equal to -4. If we add these equations together, our variable y is going to eliminate, leaving us with a -10z is equal to 0, or z is equal to 0. So we found the value for one of our variables. We found the value for z. Now let's go back in equation 4 and solve for y. Equation 4 is 5y minus 5z is equal to 4. That's equation number 4. Let's substitute z equals 0. So 5y minus 5 times 0 is 4. In other words, 5y is 4, or y is equal to 4/5. So we've solved for 2 of our variables. As a last step, let's go back and solve for x. And I'm going to pick equation 1 to do that with. Equation number 1 is 3x plus 5y plus 3z is equal to 2. That's equation number 1. Now let's substitute our values that we know. We've solved for y and found that it is 4/5. We've solved for z. We found it to be 0. Now let's take this equation and solve for x. So 3x plus 4. This term cancels. That's equal to 2. 3x then is equal to -2, or x is equal to a -2/3. So we've solved for our three variables. We believe that x is a negative 2/3, y 4/5, and z is 0. It's always a wise idea to go back and check these values in your original three equations. If you do that, you will find that that check does indeed verify that our solution set is x equal negative 2/3, y is equal to 4/5, and z is equal to 0.